Good morning. Welcome to Village in Motion. Today is Friday, January 10th, 2020, and we are here today to encourage you to get out of your apartment, get out and join a group and find something to do on these cold, dark winter days. And to start our program this morning, we have Rich Schmidt, who you're well familiar with because you're here often, because you know about so many things. Good morning.
Good to be here.
We're happy to have you. So let's start with cosmology. There is a cosmology group, right?
That's correct.
And what does, I don't even know what cosmology is, let alone what your group does. Can you give us a little teaser?
Sure. We started out with Al Weinstein many years back, probably around '02.
Okay.
I moved here around '05, and I saw that they had this cosmology group, and I said, gee, I'd like to take a look at that. Mm-hmm. And he ran that for about 10 years. And he kept all his notes, but he couldn't do it any longer. And so I took over and used his notes, and I just try to update those notes. It's all about the study of the cosmos, and that's why they call it cosmology. There's the stars out there and how it all began. It's very interesting. All the planets that are out there, we didn't know there were planets.
We're talking about everything outside the Earth's surface.
Things on Earth. How did life develop on Earth? We're interested in that. Is life, like on Earth, developing elsewhere? Is it on our moons around our planets? Could be. Is it around planets that are around other stars? Could be. That's the big question.
Lots of theories.
Yeah,
and lots of research going on.
But our group doesn't try to get you into the technicalities of it.
Thank goodness.
We keep it down so everybody's welcome.
Good.
Okay.
So is this something you were interested in before this?
Definitely. I've always been interested
so this
in
gave you an opportunity to really share what you'd learned and learn more.
It takes a lot of study to pick up on these things.
I'm sure it does.
And then bring it down to the level where everybody can appreciate it.
Well, that's interesting. So I think we have some pictures to show. Let's see what we're looking at.
The first one up is a black hole. You've seen that in the...
I've heard the word, but I don't know what it means.
Yeah, they have it in the newspaper every once in a while, something about a black hole. What the heck is it? Mm-hmm. It's a very massive object. It's got a lot of mass. What is mass? Mass is the solidness. You got a ball and it's really hard. That's a mass. Okay, well, a sun is a mass too. It's a mass of gases, but so much gas that it forms a nuclear reaction because of the compression from gravity. It gets so hot inside that it starts cooking the atoms together and they start mashing together, and you get a lot of energy out of that.
So a black hole, I guess I would have thought of similar to a donut hole, is nothing, but you're telling me it is really something.
When you get a huge, huge star and it runs out of fuel, it collapses. And when it collapses, it can form into a nuclear body, which means there's no electrons free around it anymore. Just the center of the atoms are there, all crowded together, very tiny. But if it's even more massive, it collapses to nothing, to a tiny point. And so now you got the masses there, but you can't see it. It just is so massive that the gravity is so strong, even light can't escape. Well, if light can't escape, how do you see it?
Then we can't see it, and that's why
we did get a picture though recently. It was in the newspaper.
I remember reading that.
Right.
Yes.
It said what was going on was that black hole was bringing a lot of gas around it, and the gas would glow. We got a picture of the glowing donut. Okay, and so that's how they got.
So we were seeing a glow.
The glow of the gases being brought into that hole. If it disappears into the hole, the light goes away. But all the stuff on the outside still is glowing, and we can take the picture. And that's the first time they ever got a picture of a black hole.
I remember seeing the people being interviewed.
This image that I had up there was an artist's drawing. That was not an image that we took a picture of. And the artist was depicting that black hole in the center there is attracting the gas from an associated star. That bright glow to the left.
To the left, okay.
Is being sucked into that hole, and as that gas goes in, it brightens up.
Interesting.
Okay? Yeah.
So
that's one of the things we talked about.
Yeah.
The next image we'll bring up is a landing on Mars. we were able to successfully land on Mars, and this was a very sophisticated approach. As it came down, you had to open up a parachute to slow it down. Then you had a rocket motors after the parachute couldn't do any more. And then the rockets would have blown up dust off the ground, so we didn't want that.
Right.
So they had a tether coming down 20 feet down, so that it stays up there, lowers it onto the ground, and then flies away. They detach the tether, flies away, and now they this Curiosity that came down, that picture that I showed you, that instrument was about the size of a car.
Wow.
So that's no small device, and that's why they had such a sophisticated way of getting it down onto the planet's surface, and sophisticated but successful.
Yes, they look so fragile.
Yeah, pretty neat. The next picture that I got up is a moon of Saturn. This moon, going around Saturn, gets around in about 33 hours. That's a pretty fast orbit, okay? Well, there's another moon that's a little further out called Dione, and that comes across the path of that, not comes across the path there, comes next to it every second time. So it goes around 2 times, the other one is going around once, and they get together.
So these are moons that really belong to Saturn.
They all belong to Saturn, but the change in gravity is causing this moon to squeeze a little bit and release, squeeze and release. Heats up the center, which melts the ice that's above it, and they got an ocean under there. And we can tell there's an ocean, and it's spewing out some particles through the ice that's above it. It melts the ice above it and puts out these little geysers.
Wow.
And so we come across things like that. Then we get to the big issue. Where did everything come from? The Big Bang. Come on now. Who can believe that, you know?
Well, people will believe a lot of things.
They extrapolated back. They saw that the whole universe was expanding. We can certainly measure that. There's no doubt about it that it's expanding. Well, if it's expanding, it must have come from a smaller place.
Right.
And you keep going back through the theory, it comes to a point. Come on, what happens when you get down to a point? Well, the theory says that at that point, the temperature is so high, everything comes apart. All the atoms come apart, everything is floating around. Even light can't come out. But after a while, it expands out to the point where light can come out, and that says there should be an afterglow. Well, if there's an afterglow, we should be able to see that today.
Yeah?
We should be able to go back. And we did. We went up, we measured it, and sure enough, there it was. It was predicted to have cooled down from 3,000 degrees to 2.73 degrees.
How exciting that must have been.
And it was there, right at that temperature, just as predicted.
That's exciting.
And then we went up and we took, we have the next picture. Yeah, that was taken, and believe it or not, this had a temperature so constant that we had to look at the tiny deviations in the temperature. 1 part in 100,000.
Wow.
Holy cow. And that's what it came out. And we can see that the dark spots are where there's hardly any mass. Where the brightness is, there's more
Where there's
mass.
something there.
And you compare that to the sky today, and by golly, all the bright spots are where galaxies are. And when we look at where the emptiness is, there's emptiness of stars. There's no stars in those areas.
Right in that state.
Yeah.
Right in that place now.
And so this is proof of the Big Bang Theory.
So that's
really
interesting. We've got to move on so we have time for our second subject.
Yeah.
But I want to tell people, if you would like to learn more about cosmology or share what you know about cosmology, you can go on the second Wednesday of every month, every other month.
Every other month,
Thank you. Second Wednesday of every other month, and this is always advertised on the scroll in the Village Bridge, at 2 o'clock in the afternoon in the Hunters Crossing classroom.
All right, second Wednesday, the next one will be in March.
Okay.
Okay?
Good. So learn about cosmology. Now, our other subject today is something else that you've become an expert in, and that is the game of Sudoku.
Yeah.
which looks like, I think they have a slide up to just show, if you've
Yeah.
never played, this is what it looks like.
If you look at it, it's a 9 by 9. And you got 9 little boxes going across, 9 rows going down. And I put the letters up there, A, B, C for the first 3 columns, and so on across. And then 1, 2, 3, and so on
For the
down
rows.
for the rows. So that somebody coming to our group will call out, oh, there should be a 1 in such and such a place, or there should be a 2 in such and such a place. They can say it's in column C, row 3.
Okay.
So we all know where we're talking about.
So what, in the picture that we're looking at, what are the numbers in parentheses?
Okay, we'll start off with the numbers that are not in parentheses.
Okay.
Those are the black numbers.
And those are on the puzzle when
Those
you
are
get
the
it.
ones that are on the puzzle, and you're trying to solve this puzzle. And the neat thing for seniors is that you know all the answers. You do a word puzzle, you don't necessarily know all the answers unless you've been keeping up to date in all the literature that's going on
Sure.
in movies and actresses and so on. Here you know the answers are 1 through 9. That's it.
That's it. There are no other.
There are no other
you don't
answers.
need to know
okay?
any more than that.
And every row is supposed to have the numbers 1 through 9 in it without
Mm-hmm.
repeating. Every column has to have a 1 through 9 without repeating. And if you noticed in that illustration, there were major boxes. There were 9 small boxes within every major box.
Right.
Okay, and you had to have 1 through 9 in there without repeating. So it's the same rule applied in 3 different places, so you know all the rules already.
So this is, we're down to just a minute or so here. So I understand that there's no math involved,
No, it's all logic.
that it's all logic.
You can have pictures instead of numbers.
And if someone comes to one of our Sudoku groups, they can learn how that logic works.
We try and show you, we tried all kinds of different methods, and we came up with a method that is nice and simple. It's rigorous. As you go through, you do it rigorously, you'll solve every puzzle that's solvable logically.
And you'll have a skill that's something you can carry with you. And if you have 10 minutes in the doctor's office, you can work on a puzzle
It's very convenient.
and keep your mind working.
That's right.
Yeah. So your group meets, then there are 2 Sudoku groups. Your group meets every Monday
That's right.
from 10 to 12 in the Hunters Crossing classroom. And there's a second group that meets at 1:30 on Wednesdays in the Village Square cards room. So 2 different possibilities.
Now on Monday, we have a problem with the 3rd week of the month.
Okay.
We have to go in the cards area because there's another group that preempted us into the
But you're in Hunters
classroom.
Crossing and people can
Both
kind of see
places.
that it's right
Yeah.
next door.
Yeah, that's
Yeah.
correct.
That's good. So it's a good game to learn, good game to come and learn how to do it and to do it with others and get out of your apartment a little bit and learn something new.
There you go.
So thank you so much for introducing us to 2 ways that we can really get our brain cells moving around and thinking, especially the whole cosmology thing just is something that's outside the experience of any of us as far as something we've looked at. So that's a good way to find something new for the new year to try and learn about.
Welcome everybody.
There you go. Thanks for coming, Rich. We'll see you soon.